27 topics.
Oh,
There are 27 topics, and I'm showing you the topics at a glance. All the topics. Here you see the first topic is physical quantities, units, and measurement.
mm,
And it is section 1, general physics. After this, we have section 2, Newtonian mechanics. In Newtonian mechanics, we have 6 topics: kinematics, dynamics, mass, weight, density, turning effect of forces, deformation, pressure. These 6. Then we have section 3, energy and thermal physics. And in energy and thermal physics, we have energy sources. We have 5 topics here: energy
oh,
sources and transfer of energy, transfer of thermal energy, then temperature, thermal properties of matter, then kinetic model of matter. After this, section 4. Can you read in section 4 what is written?
waves, general properties
Waves.
of
Yeah, general wave properties. There are 4 topics here in waves. Then topic 14, what?
light,
Light. Topic 15, what is it?
electromagnetic spectrum,
Electromagnetic spectrum. Then topic 16,
sound,
sound. Here. So these are done. Waves done. Now section 5, electricity and magnetism. 8 topics. Can you read the topics?
magnetism and electromagnetism,
Yes.
static electricity,
Then
current electricity,
current electricity.
DC circuit,
Then
practical electricity,
yeah.
electromagnetism, electromagnetic induction,
Then
uh,
introductory electronics. And finally, electronic systems. Afterwards, we have 2 more topics in section 6. In section 6, atomic physics, we have which topic? Topic 26. Can you read?
radioactivity,
Yeah, then,
the nuclear atom.
okay, these are the 27 topics, and I yesterday uploaded in Google Classroom. Did you get the email?
Yes, sir.
Yes, please check out the Google Classroom before and after the class when I am uploading all these materials. Then you can be updated, right? Now, our plan is to finish all these topics uh, by by Jan. Okay,
Mhm.
by January we are going to finish all this, and after that we will have revision, revision and mock exams.
Oh,
Okay, till before the final exams, Cambridge exams, we will have the mocks and revisions. So the first topic is physical quantities, units, and measurement. And I prepared one notes according to the learning outcomes. You see, for each of the topic, there are some learning outcomes. Here, can you read the learning outcomes here?
and define the term scalar and vector. Determine the resultant of two vectors by graphical method. List the vectors of and list the vector and scalars from distance, displacement, length, speed, velocity, time, acceleration, mass, and force. Describe how to measure a variety of lengths with appropriate accuracy using tape, rules, micrometers, and calipers. The use of vernier caliper is not required. Describe how to use a variety of time intervals using clock and stopwatches. Recognize and use the conventions and symbols contained in science, symbols and systematics. Association for Science Education 2000.
Okay, so these are the learning outcomes, and depending on these learning outcomes, we prepared the notes. I'm opening the notes. Give me a minute. Here. Okay, here is the notes. You see, at the beginning of the notes, I gave the learning outcomes, and then I started the notes. Here you see, we started with scalar and vector. Can you tell me what is called scalar quantity?
A scalar quantity only has magnitude and direction.
Yeah, scalar quantities have only magnitude. What is called magnitude?
Definition the mone nai.
Okay, magnitude means, look, in my notes I gave you, because some of the students, they actually know magnitude, but what is magnitude, uh, they cannot say. That's why I gave it. Okay, magnitude means numerical value.
Oh,
Okay, and I also gave the example, uh, like speed is a scalar quantity, and we express it at 5 meter per second. For example, a car is traveling at 5 meter per second speed. So here 5 meter per second, this one is the magnitude. Okay, it's a
yes, sir.
numerical value. It is magnitude. So scalar quantity only have this numerical value. But when we are saying vector, vector has direction, right?
Yes, sir.
And how we express the direction, like we are saying a car is traveling, a car is traveling at a velocity of 5 meter per second towards east. So here we are mentioning the direction, right?
Yes, yes, sir.
So it is showing us the direction. You understood the difference between scalar and vector quantity, and some examples. Examples of vector and scalar quantity, look here. Can you read the examples?
Distance, time, mass, temperature.
Yes. Then for vector quantities,
Displacement, velocity, acceleration, force, weight, moment, momentum.
okay. So these examples are enough for you. We have some more quantities, those we need in upper classes. Look, by only this part, scalar and vector with this heading, this part we covered two learning outcomes. You see the learning outcome A and B, we are done. Here we have, look, learning outcome A and C. These two learning outcomes are done, right?
Yes, sir.
Determine the terms scalar and vector, and list the vector and scalars from distance, displacement, length, speed, velocity, time, acceleration, mass, and force. So we are done with this Two learning outcomes. Now we are going for another one. Here we have determining resultant of two vectors. We have in vector we have the direction, right?
Yes, sir.
So if two vectors or two forces they are working in the same direction, they are added, right? And we are getting 10 here, right? 3 plus 7, 10. They both are working in the same direction.
Yes, sir.
But if we are getting two vectors with different direction, like 10 is working right side and 3 is working left side, so we are getting 10 minus 3 is 7. Clear to you?
Yes, sir.
And the last one you see 4 and these 4 both are working upwards, so they are also in the same direction, and the answer is 8. You know about x-axis and y-axis, right?
Yes, sir.
Here x-axis and y-axis, if you draw, this one is x and this one is minus x, right?
Yes.
And this one is y, this one is minus y. So look, the vector calculation also following these xy symbols. If it is working left, it is minus. If it is working right side, it is plus. For the forces working parallelly, that means in right and left. And if the vectors are working upwards or downwards, that time we are using positive or negative this way. Here both the vectors 4 and 4 they are working upwards, so we are taking here positive. If we get any vector like working downwards, we are taking negative. Okay. For example, if I give here one vector like this, and it is minus 6, then what will be the resultant?
-2.
Yes, very good. Then it will be minus 2 and the direction of the vector will be like this. Okay,
Mm.
clear? The
Yes, sir.
resultant direction will be like this. Is it clear to you?
Yes, sir. Clear.
As it is minus 2, that's why the direction should be, the resultant direction should be downwards. And look here, if I give here minus 7, then what will be the answer? What will be the resultant?
-4.
Yes, minus 4. And what will be the direction of the vector? It will be no more right side,
Arrow
it will
will
be
be left
left
side.
side. Okay,
Yes, sir.
clear now?
Yes, sir. Clear.
And if I give here minus 10 instead of 10, if it is minus 10, it is like this. Then what will be the resultant?
-13.
Yes, it will be minus 13. And the vector symbol will be bigger, right? Here.
Yeah.
It will be long in size. And it will be showing the direction left side. So this These are the calculations or working when the vectors are working parallel. But if the vectors are not working in parallel, then how do we calculate them or how do we add them? That is with the use of graphical method. We will try to understand that one now. The next page. Here. Previously you got the vectors are working parallel, right?
Yes, sir.
They are working parallel, but now we are getting the vectors which are not working parallel. They have some angles in between them when they are working. When we have parallel, we have either um, 180 degree or 0 degree, like 3 and 7. They are working parallel and they have 0 degree in between them, right? Because they are working in the same direction. But 10 and minus 3, they are working in opposite direction. So they have the angle 180 degree. Clear?
No, sir. Budlamma.
You don't understand. Okay, I am showing it clearly. No problem. This one is, a bit more deeper knowledge. You will understand it now. Like this one, right? I'm drawing this one, and again I'm drawing another one, this one, together. Okay, so their angle is 0 degree. How much angle? They are working in the same direction. They have angle 0 degree. That means they have no difference in angle, right?
Yes, sir.
Their angle is 0 degree. And when they are working in opposite side, one is 3 degree. Yeah, sorry, 3 minus 3 is working this way, and 10 is working in opposite side. Then their angle is 180 degree. Okay, here it is 180 degree.
Oh, yes, sir.
Here, so
Yeah.
these two vectors, the last two, these two, they are working parallel. They also have 0 degree, right? They are
Yes,
working
sir.
in the same direction. When the vectors are working in the same direction parallelly, then they have 0 degree angle. Clear? But if they are working in opposite direction, they have 180 degree.
Yeah.
Like you and your friends, you are pulling one rope in the same direction. Then that time you have only 0 degree, right? You have no angle difference. But if you are pulling the rope in from the opposite direction, that time the angle difference is 180 degree. Clear now?
Yes, sir. Clear.
Abir, clear it? Is it clear? Hello?
Yes, sir. Clear.
Okay, done. Now we are going for next one. That time we have angles, right? Here, look, we have two vectors, A and B, and these two vectors are working in a way that they have some angles. And how to determine the angle? We have one method that is called head to tail method. Look, this is known as head to tail. That means these vectors, they have one head and one tail, right?
Yes, sir.
Can you see the head and tail? The arrow side is called head and the other side is called tail.
Tail.
Just a second. Okay, now look, here I said head and tail method. This one is head and this one is tail, right? And for the other vector, look here we have here head and tail. Okay, now I'm going a little bit down. Look, this head I placed here, right? Can you see the torch?
Yes, sir.
This head I placed here, and according to the direction it has here, I am just setting on a blank space, keeping the vector in the same way, A, right?
Yes,
And
sir.
the other vector, its tail, I am connecting with this head with the same angle, the angle available there, right?
Hmm.
Just a parallel vector of P. You see here B is a vector, right? So a parallel similar to B I am placing here, right?
Yes, sir.
So when you will draw, you should maintain it. Then it will be correct for you. Like when you are replacing A here, then you should draw it parallel to with your ruler. You will understand it is parallel or not, right?
Yes, sir.
And also for B you will get this one parallel here, and you connect the tail with the head. Okay, and that's why it is called head to tail method. And now you are getting one angle in between them, right?
Yes,
Other
sir.
than 180 or 0 degree, you are getting some other angles, right?
Yes,
Maybe
sir.
it will be 130 degree or 140-degree angles if you measure with the protector in between A and B. So this after adding these two in this method, head to tail method, we will join this tail and this head, right? Here
Yes,
we
sir.
will give head and here we will give tail. Okay, clear to you, Abir?
Yes, sir. Clear.
The side you started with tail for A, that side will be tail, and the side where you ended with B, head, that side will be your head of the resultant, and it will be giving you the direction of the resultant. And if you measure with your ruler, for example, A, if it is 2.5 centimeter and B maybe it is 3.5 centimeter, then 3.5 centimeter if it is 3.5 Newton, and 2.5 centimeter. If it is 2.5 Newton, then you will get the resultant using the ruler. For example, your ruler is giving it as 4.5. Okay, the resultant is how much?
4.5.
For example, maybe it is 4.5. Then your resultant will be 4.5 Newton. This way, using the graphical method, we measure the resultant of two vectors which are not parallel. Okay,
Yes, sir.
Abir,
Yes, sir.
you understood it, right? And
Yes, sir.
this method is also known as triangle method. Other than head to tail method, it is also known as triangle method, because you see here we got one triangle, isn't it?
Yes, sir.
So this triangle, how does it work? Look, uh, I made the method here or the rule here. For example, we got these two vectors, right? A
Yes,
and
sir.
B. If we represent these two vectors as two sides of a triangle in the same direction, you see A and B, they are in the same direction. If you start from here, then they are going in the same direction. But the resultant we are getting in the opposite direction, right?
Yes, sir.
Resultant is going opposite direction. So I made the rule this way. If two vectors are represented by two sides of a triangle in the same direction, then the third side in opposite direction represent the resultant of those two vectors. Clear?
Yes,
So
sir. Clear.
here is our third side of the triangle. We are completing the triangle, and the opposite side direction is giving you the resultant. So you understood it, the triangle method or the head to tail method, right?
Yes, sir. Clear.
Okay, you are clear. Very good. Now we are going to next. You have another method that is called parallelogram method. Okay, like A and B, if we are given two vectors f1 and f2, right?
Yes, sir.
Hello, Abir.
Yes, sir.
We are given two vectors or two forces f1 and f2, then the diagonal across or through the two forces f1 and f2, that is giving us the resultant. You only given look here in question, you will be given only these two sides. Okay,
Yes, sir.
then what you have to do, you have to complete the parallelogram. What is called parallelogram?
All the sides are equal.
All the sides are equal and the opposite. Look, this is not the like all the sides are equal. That will be rhombus. If you said all the sides are equal, it could be rhombus or it could be
Oh,
uh, what, square.
yes, sir.
But for parallelogram, you should say the opposite sides are equal and parallel.
Yes, sir.
Clear? Like this one, you have f1 is a bigger, right? Bigger side, and f2 is a smaller side.
Yes, sir.
But the opposite side, when you will complete the parallelogram, you should maintain that they are parallel. You will draw a similar side here, which one will be equal and parallel, right?
Yes, sir.
And also here you will draw another side which will be equal and parallel to F2. Okay, this way, after completing the parallelogram, you should take the diagonal from this corner to this corner. Okay, look, we have another diagonal here, right?
Yes, sir.
But we are not taking that one. We are taking that diagonal which is going through these two vectors, the given vectors. Here
Yes,
too.
sir. Yes, sir. Clear.
So this one I made the parallelogram method or parallelogram rule. Can you read this?
If two sides of a parallelogram represent two vectors, then the diagonal through them gives the resultant of those vectors.
So here I wrote through them, right? The diagonal through them.
Yes,
This
sir.
one is very important, right? You cannot
Yes,
take
sir.
this diagonal. You have to take this one.
Yes, sir.
Okay. So uh, this one is giving you the resultant. And similarly, like before, with the protector, you will measure the angle here.
Yes, sir.
Okay. You will say that what is the direction. Sometimes in O levels, it's not coming too much that you are going to measure the angle or the direction of the resultant, but sometimes they give you. That's why you have to know that you have to use protector to find the angle here, and you will say that the resultant makes, for example, here we are getting 30 degree, right?
Yes,
Around
sir.
30 degree. The resultant is making 30 degree with force F2 or vector F2. Clear?
Yes, sir.
That one is giving you the direction. So we are getting the resultant and also the direction of the two vectors using the graphical method. Okay,
Yes,
graphical
sir.
method is triangle method or parallelogram method. Okay, any one you can use. Which one you
Yes, sir.
prefer, you can use any one. So till now, what we learned what is called scalar and vector quantity, right?
Yes, sir.
With examples,
Yes, sir.
right? And we got some examples of vector and scalar quantity here. Then we knew the addition of two vectors working parallel when they are working in the same direction or in the opposite direction, right?
Yes, sir.
Then we got finally triangle method and parallelogram method.
Yes, sir.
So after 10 minutes, I'm giving you a break. After 10 minutes, we will start again. I'll give you the same. I will give you the same, password and ID. Okay. So after 10 minutes,
Okay.
you just join. No problem.
Okay, sir.
Thank you.
Okay.
Thank you so much.